Alright, in this one we'll be talking about Euclidean geometry, which is circles, quads, and tangents. If you're joining us now for the first time, I'd like to welcome you. This is the paper 2 touch-ups where we discuss about the things that we need to know. So just be sure that you don't forget to subscribe so that you won't miss when another one gets uploaded. So without further ado, we're going to start off with the Euclidean geometry. Here I'll be showing you how to basically look into the information that you're given and find basically all the angles and everything that you're gonna need before you can answer the questions. So let's jump right into it. Now in the Euclidean geometry, what you need to know is that when they question you, you'll notice that before they go to questions, they give you instructions, right? So they will give you an instruction and also they will give you a diagram. So I know that some people, they're struggling with Euclidean geometry, but you need to understand that Euclidean geometry, even though it is difficult, all the answers for the questions that you're about to be asked or that you're about to answer are all in the statement and in the diagram. So how they give it to you in the statement, they're gonna give it to you using sides. So you need to be able to find keywords and be able to find angles on those keywords. So here what you're going to do is we're gonna read the statement and we're gonna take out all the information that we're given, and then later we're gonna be showing you how you can find other angles that they were not mentioned but shown here in the diagram. So the question here, question 5, goes as follows. In the diagram below, PQ is a tangent at Q. PRS is a secant of a circle RS TWQ. RW cuts SQ at K and QT at L. PS is parallel to QT and RS is equals to TW. So, alright, now here what we're going to do is the information that we got there. What you need to do is you need to regard that one as the information that you're given. So basically what you're going to do here first, I'm going to show you how you can write an information that you're given, right? So let's write this given. Okay, so let's go ahead and see what is it that they gave us there. So in the information, they said that the first thing that they give us is that PQ is a tangent. So whenever you see an instruction in Euclidean geometry that says that a line is a tangent, so in this case it's PQ, let me just confirm that, yep, PQ tangent, right? The things that should come in your mind, if it said tangent, which is singular, tangent, the things that should come in your mind is the theorem that looks like this. So there's a theorem that says if there's a circle and there's a triangle, its vertices, all its vertices, they touch in the circle, and then there is a tangent touching to one of its vertices, then that tangent, the angle this side, the angle this side is going to be the same as the angle on that side, and the angle this side is going to be the same angle that side, right? So basically this theorem, it's called tan chord, right? So every time when you see a tangent, this should be the thing that you think of. And then secondly, when there's a tangent which is a singular, another thing that you should think of is the line, a center, right? If there's a center, then there's a line perpendicular to the tangent, right? From the center perpendicular to the tangent, that line and the tangent, they're gonna form an angle of 90. Alright, so now here basically from what they've given us, what you're going to do is first we want to look if we do have this structure and this structure first, right? So here what I'm going to do is I can see that this is my tangent PQ, right? So I'm going to look for all the triangles, right, that have their vertices touching into the circle, right, and having one vertices touching into the tangent, right? So which means to get that, I'm going to start where the tangent ends or where the tangent touches the circle, and I'm going to draw a triangle there. So the first thing that I see here, I can see this triangle. You see this triangle, TWQ, I can see all its corners are touching a circle, and this one last corner is touching a tangent. So basically that's a 10 chord. So we said if that's the case, then this means this angle, right, is going to be the same as that angle, right? So this then means now, first things first, to find the 10 chord, we're going to look into triangle TWQ. TWQ. So in it, I can see that Q1 plus Q2 plus Q3, Q1 plus Q2 plus Q3 is equals to W1 plus W2. So that's the first triangle that I see there. Now let me see, is there another side there? So you can see there's no other side, so which means now let's go ahead and look for the second one. So the second one that I see, it's this one again. 1, 2, 3, right? Now that's the second triangle that I see, which is P, which is R. Okay, let me just draw it clearly. It's R, Q, W, then back to R, right? So it's triangle RQW. So what does this one say? It says that this angle is going to be the same as that angle. So we're going to say RQW. So the second triangle that we saw with the same shape, it is triangle RQW. So RQW, I can see that Q1 is the same as W1. Alright, let's see, is there another triangle there? Okay, so I see a third triangle, so let me remove this one. So we've already done the first one, which is TWQ, and now we did RQW, and then the third one. Alright, there it is. I see a third one. Okay, now in the third one I can see that it is SRQ. So this then means now this angle Q1 is the same as that angle. Now do you see how easy it is, right? So the angles, they are just popping up. So SRQ, third one is S triangle SRQ. So in SRQ I can see that Q1 is equals to S. Now from just this information, do you see here that we can see that W1 is the same as S? Can you see that, right? You can see that here Q1 is also S, basically, because if Q1 is W1 and Q1 is also S, it means W is S and Q1 is S, basically, right? So it means also W1 it can be replaced as that, but just here I'm just showing you how you can basically find the angles that you're going to need here, né? So basically let me just write here in blue that if Q1 is W1 and Q1 is S, it means now W1 is also S. But we're going to see this one. We're going to see this one, right? Okay, now let's look at for this structure here, because we're done with this triangle now. I can see it's 3 of them, so I can't see any triangle now. So we're done with the tangent, because also I don't see a circle here. So this then means now this one we're not gonna use this one. So let me just cross it and then tick this one to show that we've used this one. Now let's go ahead and look into the second statement. Now please be sure that you understand that here we all got this. Like we got all of this from just the statement that said PQ is a tangent at Q, right? So this means now the information, you see, it has a lot of angles, hence it's important to understand what's happening. Okay, now the next sentence says PRSQ is the secant of a circle RSTWQ. But now that one, there's nothing we can get from this one, so we're gonna skip it. RW cuts SQ at K and QT at L, right? Skipping that one also. PS is parallel to QT. Alright, so that's another one. PS parallel to QT. Okay, let me just add this one. See if I can edit this one here. PS parallel to QT. PS parallel QT. Now, what happens when you see parallel lines, right, in the Euclid? Now, in Euclidean geometry, when there's parallel lines, first thing that you need to look for is the shape like this. You need to look for lines that form this shape, F, right? And then secondly, you're looking for lines that form this shape. And then thirdly, you look for lines that form that shape. So this is called fan. So here, these lines, these two ones are parallel. Okay, let me just use a different color. These two are parallel, and then here these two are parallel, and then here these two are parallel. Oh, sorry, these two are parallel. Now the idea here, the first one, this is called corresponding angles. So it basically say that this angle is the same as that angle, right? So let me just write it here. It's called corresponding angle, right? Then this one is called a co-interior. So what this one says is that this angle doesn't necessarily, it says this angle, if you add it with that angle, you're gonna get 180, right? So co-interior, and then thirdly, the last one, it says, which is alternate angles, it says this angle here is the same as that angle. So we call this one alternate angles. Alright, so now we're going to start off with looking for the corresponding angles, right? So let's go ahead and look at the parallel lines first and draw the parallel lines. So parallel lines, they said here it was PS, so it means I'm going to draw a line from P to S. Alright, and then also from Q to T. So now I'm looking for a shape of F, so which means what I'm going to do is I will need to look for lines that they're cutting between, right? They're going through from one parallel line to the next parallel line and extending, right? So it means here I can see the first one, this one I cannot take it. Do you see why? Because after Q, at Q it doesn't pass after there, right? Then now here, this one RKW, I can take this one. So let's look into between the parallel lines. Let's look at the one that is now between the parallel lines. Let's look at the one that is RKLW, right? So which means now what you're going to do here now, A, you're going to say RKLW. So looking into that line, we can see that, talking about the correspondings, I can see that this part is the same as that part, because yep, so it means R3, let me just write here, R3 is the same as L1, right? So that's the first thing that I see. And I also see here that this angle, which is R1 plus R2, is the same as L2. So R1 R2 is the same as L2, right? Alright, so let me just double check. Alright, so this was the only F shape that I saw here. So it means now we are done with what with the corresponding angle. Now we're going to look for the co-interior. Now looking for the co-interior, I'll remove the angles again, and then in the co-interior I'm going to just look for a line that moves from one parallel line and join to the next parallel line, right? Now the first line that I see here is this one, PQ, right? You see PQ, this parallel line, then from P to Q it joins from this first parallel line to the next parallel line. So this basically means that this angle, if I add it with these two angles, right, my answer is going to be 180. So what's the first parallel line that I see? It's SPQT. So let me just divide this. So the first things is SPQT. So that's the first co-interior that I see, SPQT. So there I can see that angle P plus angle Q1 plus Q2 plus Q3, yep, plus Q3, they're equals to 180, right? So the reason there is co-interior basically. So what's the second one? Let me remove this one. So I'm done with that line. So this is another line. So in this line I can see that this part R2 plus R3, if you're adding with RQ2 plus Q3, you're gonna get 180. So which line are we talking about now? So now we're gonna talk about PRQT, right? Sorry, SRQT. SRQT. I see here that R2 plus, which is R2 plus R3 plus Q2 plus Q3, it is equals to 180, right? So let me extend this one. So let me see if you can find another one. Now I can see this one. Now if I'm looking at RL, this one RL here, in RL I can see that it gives me two cointeriors. It gives me these two, right? And secondly, it gives me the other two. So let me just highlight these two, these other two, right? So I'm gonna start off with the one at the bottom, which is PRLQ, PRLQ, PRLQ. Now in PRLQ I can see that R1 plus R2 plus L3, they all sum up to 180. And then finally R3 and L4. So R3 and L4, they are in SRLT. SRLT. So here I can see that R3 plus L4, they give you 180. So that's basically other angles that we given that have a co-interior shape. Let me just double check. Yeah. Now let's look at the final part, which is the alternate angle. Now in the alternate angle, we're looking for an N shape or the Z shape, right? So let's go ahead and do the same thing that we did on the other ones. I'm gonna do a line, draw a line. You can see I'm gonna start with this one. I can see PQ, I cannot form Z because it needs to be from P to Q, but then it needs to continue going to that direction, right? But PQ creates U shape. Hence, we're not going to start at PQ, but we're going to start at RQ. So RQ, starting at RQ, I can see that the only part that I get from RQ is this part, R1, is the same as Q2 plus Q3, right? So the way I'm going to write it, I'm going to say PRQT, because that's how this shape of N or Z is formed, right? So here we're starting off with PRQT. So here I can see that R1 is the same as Q2 plus Q3, right? And now we're gonna move on to the next one, the next line, that is this one. Now if you look into this line, there's two parts, right? There's first P R L T, right? And there is S R LQ. Do you see that? All right. So which means now the first thing that we're going to start off is P, R, L, and T. So if you look there, we see that this angle R1 plus R2 is the same as L4. So we're saying it's PRLT. Second one, PRLT, and in it I can see that R1 plus R2 is the same as L4. Right? And the second one, we said the second one from this line is SR LQ. Remove this one, that means R3 is the same as L3, right? SR LQ. So in this one, we're seeing that R3 is the same as L3. So here I think I'm gonna, yep, okay, because I keep missing these heads, so I just want to make sure I wrote all the heads on the angles. All right, okay, so yeah, so we got this one. So now let's look into another one. Now another line that I see here, it is this one, which is SQ. Now this one forms PSQT, right? Forming PSQT, it means now this angle is the same as this one, right? So PSQT, right? Now it gives you PSQT is the same as what? PSQT, angle S and Q3 are the same. Angle S is the same as Q3. Now do you see how we've got all these angles just from a statement that said PS is parallel to QT? Wow. Anyways, let's see if we're done now. All right, so basically we should be done by now, because we at this end of the line. So it means you're done with the parallel line, and then now we're gonna move on into the next statement. Now the next statement, let me see. Okay, we don't have space here, so we're gonna open up more space. Now the next statement, it says now here, RS is the same as TW. Okay, so RS is equals to TW. So whenever you're told that sides are equal, right, it is important that you first look for the sides, whether they are tangents or just line that are in between the triangle, right? Oh, sorry, the circle, not the triangle, the circle. Because if, which is RS equals to TW. So whenever you're given a line or two lines that are equal, right, it is important that you first look at these lines, whether they are chords or just lines that are in between within the circle, right? So the idea is that if the lines are chords, then it means you need to look for triangles, right, where their corners or their vertices all touching the circles. Because if you get those triangles, it means now you're gonna say if the sides are equal, and so as they are what? They are angles, right? So it's called equal sides, equal chords in the circle, right? All right, so here, what is it that we told here? We told that this line is the same as this line. So basically what we're going to do is we're going to look for triangles that they all touch into the circle. This then means I can see that this part forms this triangle, and then this part, it forms the other triangle, right? So What does this then mean? So it then means the angle facing in this bigger triangle, which is RSQ. So this then means in this bigger triangle, which is RSQ, this angle facing RS is going to be the same as this angle facing TW, right? So what did we write here? Is that in RS TW, and then we notice that these are the chords, right? So because of its chords, we then said that this is going to be equal sides, equal angles. But now we had to find those triangles that we're talking about, right? So we said in SR we got SRQ, so triangle SRQ, and triangle, let's look at the second one, TWQ, and then from it we're saying now Q2 is the same as Q4. Q2 is equal to Q4, right? So here we just spend a lot of time finding all these angles, and basically this is all from what? From the statement. Are we done from here? No, we're not done from here, because remember, this is only from the statement. You see how long this is, right? It's only from the statement. So now, because we've got everything from the statement, it means now we need to look in the diagram. So now once you've written everything in the statement, in the diagram it becomes easy, because now in the diagram the only things that you look for, let me just close this thing. So in the diagram, I like to call this one a glossary, because now in the glossary we have steps, right? There's methods that you're going to look for. So in the glossary, let me just write there, glossary, right? The first thing that you're going to look for is what? Cyclic chords. You're going to see if you have cyclic chords there. Now people, they like to make mistakes, right? So what are cyclic chords? So cyclic chords is anything that has like 4 sides, right? But now there's types here. It's a cyclic chord because those chords, their corners, they all touch in a circle. So I'd like to have the first one here and the other types there. Alright, the first type of chord is having a circle, and then in the circle you can see that the chord, all of its corners, they're touching there, right? So this then means now this angle, if you have this angle and then you're multiplying it with that angle, and then your answer is going to be it's going to be 180. Or if you have this angle and you're trying to multiply this one with that one, that means it's going to be 180. So here it's called two opposite interior of cyclic chord, right? So this is the shape that you're going to look for. Now the second shape that you're going to look for is going to be like this. So it's a circle. Now in this circle, still gonna be a chord, right? But now you can see that one side has extended its side, right? So this then means this part, then when you see something like that, the part where it extended is gonna be the same as the opposite interior. So you can look at this one as looking for the angle adjacent to this one, which is this one, and then look at the opposite one. So that's how you basically find the opposite interior, right? So the opposite, so exterior of cyclic chord, exterior of a cyclic chord is equal to an opposite interior. And then finally, the last one that you look for is what I like to call the butterfly shape, or the butterfly effect, I think. Let's just stick with butterfly, right? Butterfly shape. Now the butterfly shape states that if you have something like this is a quad. Why? Because it has four sides, 1, 2, 3, 4, right? Hence it's a quad. And then it's a cyclic quad because the corners, all the corners, they touch into what? A circle. All right. Now this one says if you're having something like this, then this angle is going to be the same as this angle, and that angle is going to be the same as that angle, right? So this one is called angle in the same segment. So now basically we're going to quickly go into the diagram and see which ones do we got here, and then we're going to cancel the one that we don't have and take the ones that we have. So if I remember here, we didn't have a quad, so basically we don't have this one. So we don't have this one, we don't have this one, but let's look for this one. So for this one, I can see first I'm going to look for the one thing that looks like a butterfly, okay, which is I can see the first one is this one. Can you see this one here? All right, that's the first one. And then the second one that I see, it is this one. Let me just show them first before I can go into writing them. You see all the corners, they touching into a circle. So let's basically start with this one that we have here. So this one, it's R S, it's S R, sorry, it's S R W Q S, right? What is it called? S R W Q, then back to S. So what is happening here? S R W Q S. This angle S is going to be the same as this one, angle S1. Angle S is the same as W1, not S1, it's W1. And then secondly, this angle R3 is the same as Q3 plus Q4. R3 Q3 plus Q4 heads. All right, now let's look at the second one that we had. So we just did this one. So the second one, it was this one, R Q T W, and then back to R, right? R Q T W. Second one, R Q T W, back to R. Now this one, I can see that T3 is the same as R2. T3 is the same as R2. T3 and R2, same. Let me just double check there. Yep. And then lastly, I can see that Q2 plus Q3 is the same as W2. Q2 plus Q3 is the same as W2. Q2 plus Q3 is the same as W2. W2. So basically, these are all the angles that you're going to need for you to answer the questions that you're going to be given in this type of question. Now in the next video, I'll be showing you basically how we can then answer these questions. So I'm going to see you on to the next one.